Hi everyone, welcome to this episode of Kuipert Labs. In this video I'm going to be introducing you to a new calculation technique that we're going to use called the factor label method. A way that we can make conversions between numbers, between things that we've measured or information that we're given, using these special types of fractions that we call conversion factors. Okay, so first I'm going to introduce you to what seems to be a simple problem just to help introduce the idea. So, if I have an object which I measure to be 3.5 kilograms, and I want to work out how many grams that is. Okay, now you quite rightly might recognize that there's a simple number conversion that we can be familiar with here, but that's why I wanted to start with this one to illustrate the key idea. Okay, so what we know from our understanding of maths is that 1 kilogram equals 1,000 grams. Okay, so we have 1,000 grams for every kilogram. Now what I want to do is I want to set up this particular type of fraction called a conversion factor. So I know, so for every 1 kilogram I have 1,000 grams. So I'm going to write that for every 1 kilogram I have 1,000 grams. Or I could also write it as for every 1,000 grams I have 1 kilogram. Okay, so each of these is a fraction. Notice the language I was using as I was writing them. So as I'm drawing the line for the fraction, I'm using the phrase for every. And I want you to get used to actually saying that out loud as we're doing these sorts of things, because to help illustrate the point that we're trying to make. So what I want to do is I'm going to pick one of these conversion factors, version A or version B, to help me to convert my number from kilograms to grams. Now, so what I'm going to do is I'm going to rewrite my number of kilograms here. Now I want to end up with, actually I'll rewrite that just a little lower to give me a little bit more working space. Okay, so based on what I've got in the question, I recognize that I want units of grams at the other end. So what I'm going to do is I'm going to pick whichever version of this, whichever version will help to give me units of grams on top at the end. Okay, so, and I'll show you why. Okay, so I want units of grams, so I want grams on top. So I see that version B has grams on top, so I'm going to write version B just here. Okay, and then what I'm going to do is I'm going to multiply my original number by that conversion factor, by that fraction that I've set up that shows the relationship between grams and kilograms. Now the reason that I've chosen version B in this situation is that you notice that I've got units of kilograms over here. I've also got units of kilograms on the bottom over here. Now we know from the way that fractions work that if I've got something on top and on the bottom, that they can cancel out. So my kilograms can cancel out. And what that does is that leaves me with units of grams at the other end. So what I have is essentially putting in my calculator 3.45 times 1,000 divided by 1 times 1,000 divided by 1. Now we know from maths that dividing this by 1 we don't actually need to put that into our calculator in order to get the answer that we're after. And so we get 3,450, and then I know that the units that I'm after is grams. And so that's what I'd write as my final answer. So we could have gone for a simple calculation of just kind of whack in 1,000 somewhere and hope for the best. But the reality is that these sorts of calculations are often what trip students up, because they know that the 1,000 goes in there somewhere, but they don't know intuitively whether they need to multiply or divide. And often you just end up making a guess, or you have to try and memorize it by brute force and hope for the best. In which case you're liable to make mistakes. Whereas if we can use an approach like this and actually reason our way to making the choice about which fraction to use, then we've got an intelligent path to get us the answer that we're after. Okay, now I'm going to show you an example which is a little less intuitive, a little, something that we wouldn't necessarily be able to rote memorize, just to kind of give you a sense of why this sort of approach has power. Okay, we're going to do it in chemistry a lot. I realize it's quite foreign and quite unfamiliar, and so it may be uncomfortable to get used to, but I want you to persevere with it. Consider it like training. Not everything that you do when you're training, if you're doing some, athletic training or soccer training or basketball training, not everything that you do there is pleasurable. It's not always a pleasant experience, but it all serves an important purpose in the end. Okay, so let's say I'm going to do a problem that involves money. Okay, so if I have an item that costs 120 US dollars. Okay, how much is this? In Australian dollars? Now we can look up for the day that the exchange rate is 1 Australian dollar gets us 0.72 US dollars. Okay, that's sort of information that comes up on the news all the time if you're looking to travel that you particularly care. Okay, so we can use our factor label method to help us with this calculation. Okay, so we can take this relationship, and just like we did before, we can set up two conversion factors, version A and version B. Okay, so for every 1 Australian dollar, I have 0.72 US dollars. And for every 0.72 US dollars I get 1 Australian dollar. Okay, so I've got two versions, and I get to decide which one I need to help me solve the problem that I have. So I have a number of 120 US dollars. Now I want an answer that has Australian dollars. It gives me units of Australian dollars in the end. And so that's the one that I'm going to look for that has it on the top. Okay, so I can look at A and I can look at B, and I can recognize that version A has Australian dollars on the top. So that's what I'm going to use. So I bring that over and I drop it in here, and I'm going to multiply my US dollars by this conversion factor. And I'm going to keep writing the units, even though I can recognize that I'm talking about different types of dollars, because it helps to visualize why we're doing what we're doing. Okay, so we can see that our US dollars cancel out, and we're left with Australian dollars in the end. So what I put into my calculator is 120 times 1 divided by 0.72. Okay, and if I wanted to be cautious, I could put that in brackets, or if you've got a scientific calculator, you can write it as a fraction, which I think is a really smart strategy to get used to, so that you're telling the calculator what it needs to know to do the way you want it to do, instead of it making a silly mistake. Okay, so we do this calculation, and then we end up with, rounded off, 167 Australian dollars. Okay, so we've used a relationship that we can find out. We've constructed two of these fractions we call conversion factors. We've been able to look at what we have and find out and look at what we want, and use the version that will get us to the answer that we're after. We then can work out a simple some set of steps in the calculator, and then we get the answer that we need. Okay, so the general principle of the factor label method. So we're just kind of gone through two sort of examples. So the general principle that I want you to take away from this. Okay, here we go. When using a conversion factor, you do the one that has the units you want divided by the units you have. So what you want over what you have. Put a big box, multiple highlights, asterisks if you need to. Make it really pretty, make it really obvious so that you can remember this process. Okay, because these sorts of calculations will come up all the time in chemistry. We can use them to do the most complicated, things that are so unfamiliar, but we can use this same sort of a process and say, right, well, I know that for every one of these, I've got one of these, or for every X of this, I've got Y of that. And we can use this sort of an approach. Set up a conversion factor and do our calculation. We can even take multiple conversion factors and string them together. That's kind of the power of this sort of an approach, is that rather than just trying to memorize a formula and brute force kind of smash it into our calculation and hope for the best, we can make an intelligent decision about which way round to use this to help us in our calculation. Alright, that's it for now. Thanks very much for watching. Bye for now.